Okay, we're going to go over the review for the parent functions and 6.8 quiz. To start off, we're going to need to accurately graph the 6 parent functions and give their domain and range. So we will start here with y equals x cubed. Y equals x cubed is the one I call a squiggle. The way that we're going to graph that is we're going to start at 0, 0 and put a point. And then we're going to go over 1, up 1. And then we go back to the start point, we go over 2, and then we have to cube our 2. So we're going to go over 2 and then up 2 times 2 times 2, which will be 8. So over 2, up 8, and put a point. Now when we go left 1, well, then that will be negative 1. Negative 1 cubed is negative 1, so that guy is over here, negative 1, so left 1, down 1. And then we're going to go left 2, down 8. Then we're going to graph this as a squiggle. So it kind of looks like half a parabola that's right side up, and then half a parabola that's upside down is sort of what that looks like. The domain for this type of graph is all real numbers, and the range is all real numbers as well. Now the cube root of x goes the other orientation. So on the squiggle, we're starting at 0, 0, and then we go over 1, up 1, and then we go over 2, up 8, left 1, down 1, and then we go left 2, down 8. So that's for the squiggle. But for the cube root, we are going to switch the x's and the y's. So I'm going to put a point at 0, 0. So I go 0, 0. And then instead of going over 1, up 1, I'm going to, well, I still go over 1, up 1, because 1 and 1 is the same. So over 1, up 1. But instead of going over 2, up 8, I go over 8, up 2. So over 8, up 2. And then I still go left 1, down 1. So left 1, down 1. But now instead of left 2, down 8, I go left 8, down 2. So left 8, down 2. And then this is a sideways squiggle. So it kind of looks like an eyebrow graph here, and then an upside down and backwards eyebrow graph here. It also has a domain and range of all real numbers. Absolute value of x, that is the v. It has a vertex at 0, 0. And then from that point, we go over 1, up 1, over 2, up 2, over 3, up 3. So over 1, up 1, over 2, up 2, over 3, up 3. And then it has symmetry, so also on the other side. Left 1, up 1, left 2, up 2, left 3, up 3. So this guy looks like the letter V. Oh, I should have used a ruler. Those should be straight. The domain for this graph, left to right, is all real numbers. But the range, you can see that all of the x's, all of the y's that we run into are 0 or larger. So the range will be y is greater than or equal to 0. Y equals x squared, that's a parabola. We've been doing those for a long time. So the parabola has a vertex at 0, 0. And then it follows a pattern over 1, up 1, over 2, up 4, over 3, up 9. So over 1, up 1, over 2, up 4, over 3, up 9. Did I go 9? Yeah. And then it's symmetrical. So left 1, up 1, left 2, up 4, left 3, up 9. And then we want to draw that like a nice smooth U that's not too pointy on the end, like that. Domain for a parabola is all real numbers as we go left to right on the x's. And on the range, all of our y values are either 0 or higher. So y is greater than or equal to 0. Square root of x, that's the eyebrow. The eyebrow starts at 0, 0. And then it's going to go in the reverse order of the parabola, but only on one side. We only have an eyebrow on the whatever side of your face this is over here. So we start at 0, 0. And then we're going to go 1 and 1 because, again, 1s don't change. So over 1, up 1. And then instead of going over 2, up 4, we're going to go over 4, up 2. Over 4, up 2. And then instead of over 3, up 9, over 9, up 3. Back to the vertex, over 9, up 3. And then we draw a nice little eyebrow shape. On the domain, all of the x's are either 0 or larger. So the domain is x greater than or equal to 0. And on the range, all of the y's are either at 0 or higher. So y greater than or equal to 0. This guy, this is the reciprocal function. Sometimes I call it a swoopty-swoopty because it kind of has two different parts to it. This is the one that has the black hole. So I'm going to write down here. It's got a black hole at 0, 0. You'll learn more about that coming up chapters. So I usually just put an open circle there because I can't divide by 0, so I have to avoid touching it, which is like why it's a black hole. Then I use this relationship of y equals 1 over x. So if I go over 1, then I'm going to go up 1 over 1, so 1. So over 1, up 1. If I go over 2, then I have to go up 1 over 2, so 1/2. Over 2, up 1/2. And then I want to get smaller, so if I go over 1/2, then I'm going to go up 2, because this says to flip it upside down. So over 1/2, up 2. This has a little branch over here. It doesn't touch 0, but it comes awfully close. So there's one part of it. And then by the same thing, I'm going to go on the other side, and I'm going to go left 1/2, down 2, left 1/2, down 2, left 1, down 1 here, and left 2, down 1/2. Left 2, down 1/2. And then I'm going to have another piece over here. The domain here is if I look at my x's are every single number except for that black hole. So it's x can't equal 0. And then my range is y values. My y's go everywhere except for where that black hole is. So the range would be y cannot equal 0. Now we can do transformations with all of these functions. And the transformations always follow the same rules, no matter which parent function it is. So what we've got going on here is we have 4 parent functions, as you can see, with different transformations. So there's a couple of ways to look at these problems. One way, you always want to know like what parent it is you're dealing with, and then kind of what were the transformations. So I might look at this one and go, okay, well, that's like my parabola. So it normally looks like this, which I can tell from comparing this picture to what it normally looks like that this one has been reflected across the x-axis because it's upside down. So I know I have a reflection, and that means that I'm going to have a negative out front of my equation. So if I start to look at my answer choices down here, ready? We're going to scooch. If I start to look at my answer choices down here, the parabola, its formula, do you remember what it is? Its formula is y equals x squared. So as I'm looking through my answer choices here, the only ones that could be parabolas would be this one that's x squared and this one that's x squared. And since I can tell that my parabola is upside down, I'm looking for one that has a negative out front. And since this one does not, that would be the one that matches. So that will be number 7. Now the other transformation I have listed, this is an up 5. So normally, remember my vertex is 0, 0. I can tell that it's been shifted up 5. So that is going to be a match. Let's look at our next one here. This guy is an absolute value. It normally looks like this. It's a V. And its equation is that with the absolute value bars. So in looking at this guy, I can see, again, I have a reflection, which means I would have a negative out front. And I can also see that it has been shifted up 2. Shifting up 2 means I have a plus 2 at the end. Okay, so I'm kind of narrowing things down. Let's see which possible equations could go to number 8. They have to have that absolute value bars in it to make that shape. So absolute value bars could be this one, could be this one, could be this one. Those are the only 3. Okay, so I already know there's a reflection, which is a negative out front, and up 2, which is plus 2 at the end. So this one can't be it because there's no reflection. And this one can't be it because it's a minus 3 at the end. So it has to be this one right here, which is number 8. But I want to remember what this one does right here. That 2 that's in front is a vertical stretch. So remember what that does is it takes my pattern, which is over 1, up 1, over 2, up 2, over 3, up 3, and it stretches all of my ups times 2, times 2, times 2. So then my pattern would be over 1, up 2, over 2, up 4, over 3, up 6. And if you look here, mine is upside down, so I'll be going over 1, down 2, and then over 2, down 4. So this one is the correct choice for that equation right there. Okay, next one, number 9. This is that reciprocal graph. Reciprocal. And it normally has a black hole at 0, 0, and then it kind of goes like this. And its equation, remember, is y equals 1 over x. It's upside down. So in looking at this equation, 1 over x, which ones could it possibly be? Any that are 1 over x. So it could be this one, or it could be this one. But let's look at the location of the black hole. It's normally at 0, 0, and it's now over here. So from 0, 0, I would have to go left 1, 2, 3, 4, 5, and then down 1. So I'm looking for left 5 and down 1. Remember that down 1 would be subtract 1 at the end. Left 5, that's the tricky one. The left ones are going to go with the x, but it, remember, goes the opposite side. So when we're left 1, we're going to have to be plus 5 with the x. So I'm looking for, with my x, I have to have x plus 5 instead, and then subtract 1 at the end. So here I have x minus 5 at the end. This is actually going to go right instead of left, so that can't be the correct one. So this one goes left and down. So this would have to be the one that matches for number 9. Number 10. Ooh, that's the eyebrow. The eyebrow is y equals square root of x. It normally starts at 0, 0 and goes over 1, up 1, over 4, up 2, like that. So I can see my pattern is the same, over 1, up 1, over 1, 2, 3, 4, up 2. So I don't have any stretch or reflection, but I do have a shift. So this has gone from 0, 0, it's gone right 2 and up 3. So right 2, up 3. Okay. So I really only have like 2 choices left. These 2 guys right here are my eyebrow graphs. Right 2 is going to be inside with the x, but remember it's the opposite direction. So right 2 is in with the x, but it is subtract 2 in with the x. Up 3 is add 3 at the end. So I need to subtract 2 inside. There's that. Add 3 at the end. Oh, those are really close to each other. What's the only difference here? This guy right here. What does that mean? That negative in front. It means to reflect over the x-axis. In other words, turn the graph upside down. So since this one is still an right side up eyebrow, it's a normal eyebrow, it's not upside down, so it can't be that one. So this one would have to be number 10. Okay, accurately graph each function using the keys for graphing and then state the domain and range. Okie dokie. So we have, this is a square root. Let's do this one first. Square root starts at 0, 0, and then goes over 1, up 1, over 4, up 2, over 9, up 3. Then transformations. This is a left 3, and this guy is down 4. So if my starting point is normally 0, 0, and I go left 3, down 4, that puts my new starting point at -3, -4. Then this right here reflects over the x-axis. And what that's going to do is change all my ups into downs. So now I'm going to go down 1, down 2, down 3. So I'm starting at a new point, and I'm going to go right 1, but then I'm going to go down 1, right 1, down 1. Then I'm going to go right 4, but I go down 2 instead of up. So right 4, down 2. And then I'm going to go right 9, but down 3. So right 9 and down 3. And then I'm going to draw that, and it's going to be like an upside down eyebrow. When we do domain and range, I'm going to go left to right. So all of my x's are either at -3 or bigger. So my domain will be x greater than or equal to -3. And my range, all of my y's are at -4, but not any bigger than -4. They're all at -4 or smaller. So that'll be y is less than or equal to -4. Okay, now the sideways squiggle. These ones are a little bit more challenging to draw, I feel like, but they do have a point at 0, 0, and then they go to the right 1, up 1, to the right 8, up 2. That's about as much as we're going to fit on our graph. Then they go to the left 1, down 1, to the left 8, down 2. But we have transformations. So in our transformations, we have this guy here, which is right 1, and this guy here, which is up 3. So instead of starting at 0, 0, I'm going to go right 1, up 3 to this point right here. So instead of 0, 0, it is 1, 3. And then out in front of here, I have a -2. The negative thing is going to change all my ups to downs and downs to ups. So I'm going to change this to a down, this to a down, this to an up, this to an up. And the 2 is a stretch. So I'm going to multiply my ups and downs by 2. So that is now a 2 and a 4. This is now a 2 and a 4. So from my start point, I'm going to go right 1, down 2. So right 1, down 2. And then I'm going to go right 8, down 4. So start point, right 8, 4, 5, 6, 7, 8, down 1, 2, 3, 4. Then I'm going to go over here, left 1, up 2. So left 1, up 2. And then I'm going to go left 8, up 4. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Like that. Now remember, this guy is like a sideways squiggle. So it kind of looks like an eyebrow graph this way and then another eyebrow graph that way. The domain and range for cubic and cube root functions are always going to be all real numbers. So the domain and range are all real numbers. Okay, next, we have to rewrite these functions to make them easy to graph using transformations, and then describe how you would graph it. So basically what we're going to do in here is we're going to look inside this radical here, this cube root, and we are going to find a GCF. Here's a hint. it's almost always going to be the coefficient in front of the x. So let's see if 648 divides by 216. It does. So here's what we're going to do. We're going to go y equals, make it the cube root of, I go 216 as my GCF, and then what would be left in would be x minus the 3 I just got there. And that's not going to change anything about the 8. Then the next thing I'm going to do is figure out what is the cube root of 216. So let's see. Got my math menu, go to cube root here. Cube root of 216 is 6. So since the cube root of 216 is 6, that means I can pull that out to the front. So I'll have 6 and then cube root of x minus 3. And that still doesn't change my minus 8. And now I am back to kind of a cube root function. Those, remember, start at 0, 0. So start at 0, 0. Then they go right 1, up 1. Then they go right 8, up 2. But they also go left 1, down 1, and then left 8, down 2. But we have some transformations. So the transformations we have, this is a down 8. This is a right 3. So instead of starting at 0, 0, we're going to go right 3 and down 8. So we will start at 3, negative 8. And then we have out front here, this is a vertical stretch of 6. The vertical stretch of 6 is going to multiply all my ups and downs by 6. So instead of going over 1, up 1, I'm going to go over 1, up 6. Instead of going over 8, up 2, I will go over 8, up 12. And likewise over here, left 1, down 1 becomes left 1, down 6. Left 8, down 2 becomes left 8, down 12. Okay. Next question. The graph of y equals cube root of x is shifted 8 units down and 7 units left. What is the equation for the new graph? So 8 units down means we're going to subtract 8 at the end. 7 units left means we're going to go in with the x. But remember, left and right goes backwards of what you think. So instead of minusing 7, we're going to be plusing 7 in with the x. So here's my parent function. I am going to be adding 7 with the x and subtracting 8 at the end. So my new equation will be y equals cube root of x, adding 7 with it, and then subtracting 8 at the end. Make sure you don't forget your cube root in there, because otherwise it's not the same family anymore. Okay, use our graphing calculator to solve the equation. Oh, we've been down this road a time or two, haven't we? What we're going to do is we are going to put y1 equals the left side. So negative square root, you're going to want to parenthesis that, x plus 4 parenthesis. Then y2 equals the right side. So 3 square root, parenthesis your x, close your parenthesis, and subtract 7. Then we're going to look at the graph. So let me see here. My graph already has stuff in it from last review. So clear. So I'm going to do negative sign, in y1, negative sign, then square root symbol. You'll have to put parentheses in yours. My calculator is a bit different. I'll go ahead and put parentheses. Parenthesis x plus 4, close the parenthesis. And then in the y2, we're going to put 3, and then square root symbol, parenthesis x, close the parenthesis, and then subtraction 7. Then we are going to do, I'll just do zoom 6 because that gives me a regular old standard viewing window. There's my upside down eyebrow, that's the first one. There's my right side up eyebrow, that's my second one. And then I am going to push. I need the calculate menu. So I'm going to push the button that is second. So the second button, then the trace button, And then we're looking for where they cross. So that will be number 5, intersect. So I'm going to push the 5 button. And then we just do enter, enter, enter. Which part of this is our answer? Well, in the equation, what letters are in the equation? The only letters in the equation are x's, so our answer will be our x value. So x will equal 2.25. And we don't need to know the y value. We just need to know the x value.